how many of you can perhaps remember what these three animals looked like from that video? The one that I always thought was the most neatest was the one in the middle, this one right here. Okay? Because during the video, it was one of those where you actually saw, looks like a modern, it closely resembled that of the mammals on the way its limbs worked. If you, I don't know if it really works for small dogs, but I would certainly think one that's maybe, I would say 40 pounds or heavier, when it is that they want to lay down, okay, what do they do with their back legs? Okay, doesn't one of them move over like this? Then their hind end goes down. Then they start crawling forward with their forward-facing legs. Would you tend to agree with that? Okay, so and that's what that Gorgonopsid looked like. Okay, now the reason that we would call that so much more mammalian-like as opposed to this one, because these are still both reptiles, it was in their limbs that made it resemble that of mammals. Okay, so what is the difference besides, or excuse me, what's a similarity between these three that has to do with limbs that you could say they're associated with a hynerpeton? Starts with a T. Yes, they're tetrapods, which means what? Yeah, they've got 4 legs. Okay? So, when we look at this, we've got we could say a terrestrial So, does anyone know what we're referring to when we say terrestrial? Yeah, land dwelling as opposed to an aquatic habitat. So, hynerpetons were still known to be a tetrapod that would be associated with water. Now, these are terrestrial tetrapods. And another example that we could see is their lung breathing. Now, do they rely on, how do I want to say this, their skin aiding them in respiration? And the answer is no. Why can it not do that? Because if it's reptilian-like, what does that tell you about the skin? It's scaly and it's too thick. Okay? So that's correct. So they've got a tough outer skin. Okay. And I want to say legs are at right angles, but how is that different than that hynerpeton? Because what do we say about tetrapods that are amphibian-like? Their legs may be at right angles, but there's something significant about their ventral side. Right, but that's not the case with reptiles, okay? So we could say abdomen is higher off the ground. Higher off ground. Is it right at 10:2? You need to get out of here. I don't want you to be pressed for time. Let you two decide what it is you want to do. If you need to go, that's go ahead and proceed forward. Then the last trait we want to put down, we see synapsids. Okay? And that has to deal with their jaw structure, because who were the most notorious reptiles on Earth? That's too specific. Think more broadly.
Dinosaurs.
the dinosaurs. And when we talk about dinosaurs, what sets them apart from all other reptiles? Can be, can be. It can be their teeth too. But they said they can trace their ancestor all the way back to this little guy. You're looking at a dinosaur. It's one of these probably. You're looking up. So it must mean they're fairly what? Their size. They're very large reptiles, the largest of all the reptiles. So this synapsid is what's leading to we want to say the genetic imprint that the dinosaurs would need for their specialization of their jaws. It can be traced back to this ancestor. Okay. That is our Petrolacosaurus. We've got two left. Okay? So, Gorgonopsid. Okay? One of the things we can think about, what about teeth? What about them? Remember, what was it about a Dimetrodon? Were all them teeth shaped the same? Well, they were, but that meant they had two sharp edges, which meant that was their carnivorous diet. But this Gorgonopsid was starting to become more mammalian-like because of its teeth. What about them? Okay, but what about them front teeth you're talking about? What about them? Big, well, long or very large. Yep. So, with a Gorgonopsid or Gorgonopsia, okay, large canine teeth. Then what about its limbs? What would resemble that to more mammalian-like, like horses, cattle, and those types of mammals? Something straighter, what? True, true. Where are their limbs positioned? Yes, closer to underneath. They're still a little bit to the side, but they're not at right angles like there are with those Hynerpetans and this Petrolacosaurus. So we would want to say something like legs are positioned to underneath their body. Now, that's a very vague term, but that's more so mammalian-like. The reason we would say that is a different concept, but you would say this horse here would be an example of having legs directly underneath them. We said cattle, we said horses, camels, any one of those. Those are examples of having those legs directly underneath them. And when that happens, does that increase or decrease their speed? It will make them much faster. Okay, so we'll say limbs or legs, I guess, whichever you're more comfortable with, are positioned underneath, we'll say abdomen. Okay, and last thing we want to say, these are more so like therapsids. Okay, and what that means, again, this type of adaptations they had made them resemble probably more so that of the mammals than it did other reptiles. And then finally, what might stick out most in your mind about these little Dictodons? And where would you find these animals? Underground. Okay? So, one thing I forgot to mention, Are these tetrapods, these animals? The gorgonopsids? You're nodding your head. Yes, that's correct. What's one of the things I forgot? I'll just put that here, tetrapods. Because they're not the only tetrapods. We have here, here, and then your hynurpedon. The diictodons then, okay, they are also tetrapods. But their adaptation, you already correctly pointed out, was not above ground, but more so what? Underground. Okay? Okay? Survived due to burrowing underground. Now, why was that such an advantage for them? Two reasons. Say that again. Escape from predators, and it's much cooler below ground than what it would be above ground. So, what was their diet mainly, if you remember? Like when we look at potatoes, radishes, carrots, say that again? Tubers, which means they're plants that have what? Yeah, you get the nutrients from their roots. Okay, and that's what that little animal did. Okay, since it was burrowing underground, that helped it survive by escaping predators, and it was cooler under there, and it didn't have to go far for obtaining water. Because if you eat a tuber, do you need to go looking for water? The answer is no, because you're getting that from your food source. Now, it has nothing to do with this, but it's just a coincidence that that helped them in their survival. Okay, so remember, there's 6 animals, okay? 2 that we considered as fish. Who were they? Hycoethes and Cephalapsis. Now, what's significant about that first one that's so hard to say? All the way down, get up to here. The first vertebrate, which means very similar to what you had just said. The Cephalaspis, okay, had a shield for a head, but was still a fish. I'm sorry, what's that? Oh, other characteristics that a Cephalaspis had was using its head and knowing where to go based on its memory. Okay? And let's see here. And its reproduction took place where? In the water, because it's an aquatic animal. Okay? So that sets apart the fish. Next, we would move on to that hynurpedon, which was amphibian-like. So when we look at amphibians, we can safely say 2 things. What about their skin? Smooth, and I suppose you could say slimy, because why does it have to be smooth and moist? So it can breathe with that. What about the limbs? Is it a tetrapod? Yes. Would it have claws, though, do you think? No, that's more so reptilian-like. And even the gorgonopsid would have more so claws. Okay. What about its reproduction? Water. In the water. Then, when we move to this animal, our Petrolacosaurus, reproduction then was moved to land. And if that's the case, there must be something significant with its egg. What would that be? Yep. The shells. The eggs are now encased in a shell. Okay. They're entirely lung-breathing, and they got this tough outer skin. Unlike their hynurpedons, which didn't have claws or sharp teeth like these animals would have as well. Then moving on to your gorgonopsid. Okay. Large canine teeth. Resemble mammals because of their legs. Why? Again, they're almost directly underneath their body. And then the diictodon was the lone burrowing mammal, but was also a tetrapod. Now, it's one of them things, And I know that was a while ago, but hopefully talking about these gives you somewhat of an idea. And we're not just going to throw you out in the dark. We'll show you some pictures, not today, but later on, we'll show you some pictures and reviewing upon what these animals look like. Because once you see them, you're going to be able to say, oh, well, that was the tiny fish. Oh, well, that was a hynerpeton because of its limbs and its skin. Oh, well, that's burrowing out of the ground. That's got to be a diectodon, and so on and so forth. Any questions on that? Okay. So the last thing that we wanted to do was compare what we consider gradualism as opposed to punctuated equilibrium. And the example that we gave in class, we just verbally said it. A butterfly, its common ancestor is still going to look like that ancestor as opposed to its descendants. It's not going to change. Its colors might, but the basic design is not going to change. But when you look at this, anybody would say this basic design of the equine family that we see here, they're certainly related, but it went through different changes of evolution. How the ancestor does not look at anything like the descendants. Okay? So this is what the equine family, or the species of equine, had actually gone through. The very bottom, as you can see, was the ancestor. The very top then is that of a horse. And what had happened is through changes in time to escape predators, okay? To escape predators, why is this going to be an example? Why is this going to be an advantage over that one way down there? Say that again. Okay, if you're faster, it really helps you obviously escape your predators. Okay, so that's always going to be an advantage. What you're feeding on, but mainly who's feeding upon you. So nature had selected these animals to go through short bouts of change, punctuated equilibrium, as opposed to gradual, just a slow, gradual change. Because this isn't from your textbook, this is from the zoology text. Does this make sense, though? The difference between punctuated equilibrium and gradualism. Left middle, middle, left outside, right middle, and right outside. Okay, fair enough. So what we'll do is we'll talk about that Caribbean anal lizard, and that's found on page 308. We'll talk about that tomorrow. The next 2 days we have set aside for reviewing, and then we'll have that exam then on Friday. Just a one-day exam. Okay? If we're keeping up with things, we're doing our work, we're doing the little things right, generally good things are going to happen. All right, so we will catch up to you next time.